Hi, everybody. Can you guys hear me now? All right, brilliant. First thing, I want to make sure you guys can record. So if you can't, let me know. If you're planning on recording the session, I'll give you the permission. So please check to see if you can record record the screen. If you can't, let me know. I'll give you the record permission. I try to give it to everybody, but I might have missed out. All right, brilliant. So with that in mind, let's get started with CCIE Security. It is a course that is, at this point, one of the best courses in terms of teaching it. It's got a lot of new technology that you have in this particular course. My objective today is to get started with the introduction of the course and also get into it at the same time. So what are the different topics that we'll be covering in this particular course? I'll give you an outline of what are the different things that we'll be covering. And by the end of the session, you'll also get an idea of the way I'm going to be conducting the class. So with that in mind, let's get started with the course itself. The CCIE Security course came out, the new blueprint came out in February of this year. It is one of the courses that has been it is up to date right now with all the new different devices, different technologies that are out there in respect to security. It was highly required that they did this because I was getting tired of teaching 8.2 in a CCIE Security course. So what are the things that we'll be taking a look at in this particular course? We'll start with the VPN section over here. We'll start with basic VPNs. If you've never done a VPN before, you will know how to do VPNs to the CCIE level. I'll start you with the basics of VPNs, how a basic LAN-to-LAN IPsec VPN starts. We'll take a look at NAT-T. We'll take a look at how it works with and without NAT-T. We'll do GRE VPNs, basic, but again, GRE will complement it by going into GRE IPsec. We'll do SVTI, static virtual tunnel interfaces, which is your tunnel-based IPsec. We'll take a look at that as well. So my objective over here is, even if you don't know anything about this particular technology, to start you off with the basics, but at the same time, by the end of every technology, you'll go to the expert level. All right? So once the basic VPNs are done, then we go into some advanced VPNs. VPNs like DMVPN, Dynamic Multipoint VPN. We'll take a look at GetVPN. We'll also take a look at VRF-aware VPNs. And this is a very hot topic you need to know. You need to be aware of how to do that. So basically, if you're running a VRF, inside a VRF, you have a router, and you have a VRF on the router. How do you set up a VPN to go through a VRF? What are the interactions with IPsec and VRF? All right, we'll take a look at that. We'll do VRF-aware VPNs with basic LAN-to-LAN VPNs. We'll also do it with GetVPN as well. All right, once that's done, we'll also take a look at using a certificate server, where a router will act as a CA server, and we'll do different type of VPNs based on certificates. We'll try to do GetVPN. We'll do a LAN-to-LAN with certificates as well. So you'll also get to learn how to set up a router as a certificate server, a CA server, from scratch. Any questions so far in terms of the VPNs that we've covered? Everybody okay with this? Now, one of the things I want you guys to do is be interactive. So whenever I ask you a question, because I don't know whether you have a question or not, please feel free to ask questions on the chat window on the right. So open the chat window up, keep it open. Anytime you have a question, please feel free to ask a question. I might not answer the question immediately, but as soon as I'm done with my train of thought, whatever I'm talking about, I will answer the question immediately after that. So everybody okay with this? The stuff that we've covered or talked about so far, basic VPNs and advanced VPNs. Yes? If you're okay with it, put the yeses over there. And Quaco, just put it to everyone so everybody sees your question and they can also benefit from it. All right. So once we're done with that, we'll take a look at your IKE v2 VPNs. We'll use the legacy mechanisms of the IKE v2 VPNs and also use the SVTI mechanism with VPNs. There's slight differences in the way the two work. We'll take a look at that as well. Then we go into Flex VPN. In Flex VPN, we'll take a look at DVTI, SVTI combination. We'll also do DVTI, SVTI based on NHRP, which is more like the Flex VPN flavor of DMVPN. Anybody work with Flex VPN so far or no? First iteration with Flex? It's not a new technology, by the way. This technology has been there for a while. It was first introduced in version 4 of the blueprint, but they never tested it. So this time around, they are testing it. This time around, you don't have an option but to learn Flex VPN. What is Flex VPN? It's nothing more than a combination of the normal site-to-site, LAN-to-LAN IPsec VPN using tunnels, which is like your SVTI, but it also allows you the ability to combine the capability of DMVPN, which allows direct spoke-to-spoke communication. In the same architecture, rather than creating a separate type of architecture for a LAN-to-LAN and a different one for DMVPN, Flex VPN allows you the ability under the same type of configuration to support both site-to-site as well as spoke-to-spoke, which is your, DMVPN type of setup. That's what Flex is. So the command set is different. The concept's the same. You'll get a chance to take a look at Flex VPN as well. All these different type of VPNs that you guys have over here are things that are important from the perspective of the exam as well as real life. Some of you guys might think, well, what happened to your SSL-based VPN? Is that covered or not? Absolutely is covered. But these VPNs that we're talking about over here, the VPNs at the top, are all VPNs that are router-based. Because at this time, we have not covered firewalls. I have not covered SSL or web VPN at this point. When we do the firewalls, we'll also be covering SSL and web VPN capabilities. So besides these VPNs, which these type of VPNs that you see right now are all router-based VPNs. We'll also be doing VPNs on the firewalls. You need to know how to do that as well. So we'll actually take a look at that as well. That's coming up in the firewall section. Every one of these VPNs that you see over here, I will actually show you how to configure it. I will configure it on my devices on my side. You'll see how I'm doing it. I'll explain the technology, every single command, what you're putting in. You will understand why you're doing it. All right, it's not just I'm going to be just typing it out, typing away, and you just look at it. Every command, before I do it, I will actually explain that to you guys. Good so far? Any questions on this part of the VPN? All good? All right, brilliant. So that's the case. Let's move on to the next subject. What's the next subject over here? Oops. The firewall. The firewall, we'll be taking a look at 3 firewalls over here. We'll take a look at the ASA firewall, 9.x. I think, Sanjay, it's your problem. Can you guys hear me? I think it's his problems. All right, coming back. The first firewall we'll be taking a look at it is ASA 9.x. Then we'll also take a look at the new firewall called the Firepower Threat Defense. And before we get started, I want to make sure you guys are clear about this. I want to clarify the different, this is where a lot of people get confused. About 3-4 years ago, 5 years ago, Cisco acquired a company by the name of SourceFire. Do you guys remember that? It was an IPS company. It had an IPS product called SourceFire. Cisco acquired it. When Cisco acquired this product, they put it out as their product known as Firepower. So Cisco's IPS was Firepower. So far, so good. You guys are okay with this? That replaced the older firewall that Cisco has, which was called the Cisco IPS. That was replaced by this new product that Cisco acquired from SourceFire. They called it Firepower. Now, in that type of environment that you would have your normal firewall, which would be your ASA, and behind that, they would put the IPS box, the Firepower box. And then after the Firepower would be your internal network or the DMZ, wherever you wanted to place it. Good so far. So the Firepower over here was the IPS. So after the ASA did its normal layer 3, layer 4 type of firewalling, it would pass the traffic onto the IPS, which was your Firepower, and it would do it. The other thing that they also had the capability of doing is they integrated a module inside the ASA where you could put the IPS as a module inside the ASA, the Firepower module over here. So once the firewalling was done inside the same physical box, it would direct the traffic towards the IPS. If everything was fine, it would send it back to the ASA saying, let it go through. But it was a separate module that you would install inside the ASA. The appliance that you would still get was the ASA. This was the Firepower service module. That was the other way of doing it. Good so far? So you had a separate appliance for, what do you call it? For your IPS and a separate appliance for your firewall. ASA was just doing the firewall part. IPS was doing its own firewalling. IPS was doing its normal IPS stuff. Now what they've done is they have combined the firewalling and the IPS into one box. You do have the ability to buy them as separate products still. So you can still buy the ASA as itself, 9.x, and you can buy the Firepower module as a separate module or a separate appliance. Absolutely okay. But they have also come up with a new firewall called the Firepower Threat Defense, FTD, which is one appliance, one product, which has the ability to do firewalling and IPS at the same time. 3 different implementations of it. You can either have your ASA appliance, the old ASA appliance, one second, guys. You guys, anybody else record permissions? Because I'm giving it right now. All right, so I think I gave it to the one that I needed, that needed it. So you have the ASA appliance, 55X series, whatever the 85, 45, all the 55 series, X series. Guys, please let me know while I'm saying it, because then I have to go back and forth doing it. All right, done. So ASA 55X series, you can install either the normal ASA 9.x or you can install FTD on it. The FTD current version is 6.x. But when you install ASA with FTD 6.x, you actually don't get ASA. What are you getting instead? I gave it already, Ahmed. Check again. There's a record button. So when you install FTD 6.x over there, you're actually getting the FTD that I talked about, the firewall and the IPS built in. So that ASA is no longer running the ASA code. It's called the unified code. The confusion comes in, people still thinking this is your firepower. It is not your firepower. Firepower is your IPS. This is called FTD, Firepower Threat Defense. The names are similar, so they think it's the same product. It is not. FTD actually has firewalling that is done inside it. Or if you want, you can also get a product, an actual appliance called FTD. I think there's the 4300 series or the, I'll just say 4000 and the 9000 series devices. These are actual appliances called FTD, which are running FTD software. What is the FTD software? That's the firewalling and the IPS combined. That is correct. Not ASA 9.x. I want you to get away from 9.x as the operating system, right? The ASA physical appliance is getting re-imaged with FTD 9.x, 6.x. 2000 is the lower end, yes. Or you can get a virtual image as well. So you also can get FTD as a VM. So you have all three combinations that you want. You can either do it as a virtual, you can do it on an existing ASA, 9.x or non-ASA, and then you can do it on the FTD. Yes, this is the NG firewall from Cisco, the next generation firewall from Cisco. Either one is fine, but just remember this is not your ASA anymore. You might be running FTD on an ASA appliance, but it's not running ASA code anymore. It's called the unified code. Just to let you guys know, ASA will be end of life soon. I'm not saying it is going to be end of life soon. This is your new firewall that you're going to be seeing in the future. This is the only firewall that they're going to run with. It does have certain things that they're still lacking, and they're working on it. As soon as they port those features over from ASA into FTD, ASA is out of the picture. It's going to be completely based on FTD then. It provides complete IPS features. FTD has the entire firepower inside it, plus L7 visibility, a lot more than that. It does have the ability to integrate with ICE using, I don't know if you guys know about them or not, and you will learn that in this class, called SGTs, security group tags. It has the ability to do web filtering. It has the ability to do application aware inspection, everything. It is actually a product that is sandboxing is also possible on it. Absolutely. In conjunction with other products, but it does that capability, gives you that capability as well. Because it has AMP engine included in there. So with AMP, it gives you the ability to do sandboxing as well. AMP stands for Advanced malware protection. So for the malware, it does sandboxing. It does web filtering for you as well. Absolutely. All built in. Yeah, you do have the WSA, which has a lot more capabilities in terms of web filtering, but at the basic end, you can do web filtering over here as well. And you'll see that. You'll see that as we go through the product. Good so far. Everybody okay with this? So this is something that you need to look at as what we can do in the future. You can call it a UTM. It's basically moving towards it. UTM is a type of product that allows you the ability to do a lot of different things in one box. So you don't need to buy different boxes. All this is done in a single box, and that's what it's providing you the capability doing. Fabulous type of setup. Unified threat management absolutely does. It's not managed through, it has a separate box that will be doing the management of it. It's called the Firepower Management Center, FMC. So you're not managing it through, what do you call it? Through your FTD, it has a separate engine for doing the management part of it. We'll take a look at this. You'll get a chance to see all that in the FTD section. One of the things that it also has the ability to do that in terms of the next generation part of it. Let's say you want to block all the IP addresses that are coming in from a particular nation, country. For example, you see North Korea as a threat and you don't want any IPs coming into your network from North Korea. You have the ability to block that. So you have geolocation blocking. So a lot of good stuff that you'll see. It is really a product that can actually compete with the other products. I have the NSS reports in terms of tests that I've done on the FTD in comparison to Checkpoint and Palo Alto. It has come on top. If you want, I can share those reports with you from NSS. So it's a product now that will hit the market and it will compete with Checkpoint and Palo Alto. It's no longer on the bottom tier. Absolutely no problems with that. At this point, no, they're working on it. Remember what I told you about it. There are certain features that they have not ported over yet. Okay, so once they do that, they will have that capability as well. Not right now, though. One second, guys. Guys, try to log in on time because it becomes really an issue to give record permissions in the middle of the class. It breaks the thought. All right, so that's what FTD is all about. You have a clear picture of what it is. So I don't want you guys to treat it as just firepower. Does it have firepower? It has the entire firepower. But besides the firepower, it has the complete firewalling capability as well. And the firewalling capability gives you the next generation firewalling capability, not just ASA. Actually does not have security levels. It's more like a zone-based firewall. We'll talk about the specifics later on, but I want you guys to at least have an idea of what it is all about. So going back over here, this part over here though is still ASA. This is still, as I say, the ASA firewall. So from the exam perspective, you will still need to go through the ASA. I'll start you from scratch, make you understand everything about the ASA. How do you bring it up from scratch? What are security levels? How to manage it? What routing protocols can you run? NATing, a different type of NATs. We'll take a look at the access policies, creating the ACLs. We'll do transparent firewalling on it as well. This is the normal ASA. Initialize a transparent firewall, create the access policies, take a look at ether type ACLs. Every small bit over here will be covered and demonstrated. Once this is done, we'll go into the next topic, which is redundancy. This is again, at this point, just dealing with the ASA. We'll take a look at redundant interfaces, port channels on the ASA. Once that's done, we'll take a look at the virtualizing of the ASA called security context. We'll do active standby, active failover. We'll also do clustering. Clustering allows you the ability in the ASA to combine two devices as a single device. It's not your active-active type of thing where it is dependent on context. This is actual active-active clustering. We have two different modes of clustering, span mode and individual interface mode. We'll take a look at both. All right. We'll also take a look at deep packet inspection by looking at tuning the global policy, also configuring some custom L7 policies on the ASA. Once this is done, we'll do VPNs on it as well. Site-to-site IPsec VPNs and also remote access VPNs, the SSL VPNs, as well as IKV2, AnyConnect VPNs. They're the same boxes. It depends on your rules that you specify in there. On the perimeter, you might not want to do certain type of inspections to keep an eye on the performance, where you do more deep packet inspection on the internal firewall. So the firewall itself is the same. It's just the way you configure it. All right. So site-to-site IPsec we'll do in, as well as remote access. Over here, when we talk about over here, microsegmentation in terms of what, Ahmed? No. That gets too much into the data center part of it. They don't cover it. We'll be here for a long time if we do that. So with this IKV2 and SSL, we're taking a look at your clientless SSL VPNs. And then we'll also take a look at AnyConnect. AnyConnect gives you both SSL as well as IPsec. So we'll do both. This is all on the ASA. That's one thing that is lacking on the FTD at this point. Actually, they have introduced it. In the newer version, they have introduced it. The one that we'll be covering in the class, it doesn't have it. It does have IPsec VPNs in the current version, the one that you'll be tested on. On FTD, you do not have SSL VPNs, the one that we're testing on. In the future version, which is already out, it does give you SSL capabilities as well in terms of VPNs. The current FTD, the one that is being tested, is limited to just doing IPsec VPNs, not the SSL VPNs. It is a space that is changing a lot, so you need to keep on checking with FTD in terms of the new capabilities. No, they're all 6.2, but 6.2 again is 6.21, 6.22. So with different ones, you get different capabilities. They're working on it. They're working and trying to improve it and trying to integrate the features of the ASA into it, like the clustering, the multi-security context and that type of stuff. So once we're done with the ASA, we'll go ahead and take a look at what? Configuration of your FTD. The management console versus the FTD integration. How do you set it up? How do you set the interfaces up from scratch? How do you run routing protocols? How do you do NAT? The same type of things that we did on the ASA. We'll take a look at how to do it over here. Then we'll go into the policies. We'll do the basic ones that the ASA does, and then we'll do the advanced ones that I talked about, like the application visibility, web filtering, geolocations, all those type of things. And the site-to-site VPN, this is limited to IPsec right now. A lot of good stuff in this particular section over here. It's not just from the exam perspective. They might not even cover FTD right now on the exam, but from the perspective of learning it and deploying it in real life, this section is really, really important and valuable. Everybody good with this so far? Yeses, please, and we'll move on to the other stuff. All right, good. So once this is done, the next topic that we'll be taking a look at is your content filtering. Content filtering is basically filtering traffic based on web traffic and email traffic. They have two separate appliances for that: the web security appliance and the email security appliance. WSA, as the name suggests, is for what? Web filtering, allowing you the ability to filter traffic going out of your network or coming, well, actually, this is for outbound traffic, for what websites do your people go to and visit. Let's say you don't want your employees going out and visiting, let's say, websites like gambling websites, for example. You don't want your company employees going out for adult websites, torrents, file sharing sites. You have the ability to block it based on categories. Rather than specifically specifying the website address, you say, I want to block all the gambling websites. Cisco has categorized and keeps on categorizing these websites based on news websites, sports websites. I can go on and on now. So Cisco categorizes these websites and gives you the ability to block the websites based on the category rather than taking a look at it from the perspective of an individual website. In Facebook, you have the ability to go into Facebook and say, hey, I do want them to go to Facebook, but I don't want them to do chats. So you can even go inside Facebook and block chats within Facebook. So it gives you a lot of granular control on the popular websites that you want to, maybe for social networking, you want to block them. What about the sites that are not known, basically unknown websites? You can have a policy for that. The other thing that the WSA also has the ability to do what is known as dynamic content analyzing. So let's say there's a site that is not yet categorized. So it's an unknown site, which is called the dark internet. Dark internet is sites that people are not aware of yet. Now, on the dark internet site, the sites that have not been categorized, as the traffic goes and passes through the WSA, it has an analyzer engine that keeps on taking a look at the content that is going through to this particular client and tries to apply the policy that was initially used to categorize a website. If it sees that this particular content that's going through matches the characteristics of a gambling website, for example, or an adult website that was not categorized, yes, a little bit of the traffic will flow through, but then as soon as it finds out or figures out that this is a site that should be blocked, it will do the blocking on it as well. That is done through an engine that is turned on by default called the Dynamic Content Analyzer engine. So it has the capability of doing that as well. Is that what you're looking for, Zahir, right? You're talking about the unknown sites. So you have the ability to do that. Besides that, you can also create your custom categories. So you can also say, this particular website, this site, although the category is blocked, I want this website to be allowed. For example, you want to block all news websites except for a particular website, let's say bbc.com. So you can say block news websites completely, but then you can make an exception called a custom category where you allow a particular website, or vice versa. You can say, I want to allow this particular category, but I want to block this particular website. I can blacklist a website, either by using a URL. You can do it based on IPs. You can do it by using regular expressions in the URL. So you can search inside the URL based on regular expressions and do blocks based on that as well. These two products were, again, acquisitions from Cisco from another company called Ironport. Both WSA and ESA were products from a company by the name of Ironport, which was acquired by Cisco. Now the same thing can be done through ESA as well. That's the email security appliance. So doing the same type of checks for your emails that are leaving your company, not just for web traffic, but also for email traffic. Those are the two main type of traffic that comes in and goes out of your network. So with email, it has the ability to check for email for content. It can check for malware. It can check for size. There's hundreds of policies that you can apply to your emails leaving or coming into your network. So basically for your outbound or your inbound, this becomes your SMTP relay agent. So all your mails that are going out of your network will be directed towards what? The ESA, and it will filter the mail, check the mail before it allows the mail to go out, or coming in for the external MX record for your DNS server, it will not point to your actual email server, it'll point towards the ESA. So it'll act as your email gateway for outbound as well as for inbound as well. Everybody okay with this? You guys understand that? Again, you will need to initialize the WSA and ESA on the exam from scratch. Not only enable it, but also set the policies to specify whether you want to block or allow certain type of traffic. Are they placed physically in line or are they off on the side? It depends. Both work. You can do it in line, which is called an inline proxy, or you can set it on the side as well, where you can do it based on what is known as WCCP for web WSA. For ESA, it's all done based on DNS. Can you enable AMP on ESA? Absolutely can. It has a built-in ESA. It also has the ability to integrate with the FireAmp. So you can do it internally, or you can also integrate with the external, what do you call it, AMP as well. Everybody okay with that? You guys okay with that? So that's your content filtering using WSA and ESA. Now from the previous exam, some of you guys might have gone through the older exam. Although on the older exam, the WSA was still there, it's still there the same way on this one, but they have also included the ESA part of it on this particular exam, which is good because now you have a complete set of security set up. I personally like this blueprint a lot because it actually gives you a full rounded knowledge of a security environment using Cisco. And trust me, I've been in this industry for a long time. This is the first time I feel confident that Cisco can compete with the other products. And I'm so glad that I can actually do this class now. Before, when I would do a security class, it was like, God, don't let people ask me about ASA is so old, because it was, and it's the truth. Network automation is also there. What do you mean by, what do you want in terms of network automation? Define automation. What do you mean by automation? What do you want in terms of automation? If you do automation with security, not a good thing to do, because with, well, that's not just for security. It is something that Cisco is doing as part of its overall thing, that it's giving the ability to the users to develop their own applications to integrate with their devices. So that's not just for that. That's for any type of device that Cisco has. They have made their APIs available so that you can write your own applications. So that's not a security thing, but security I would not automate, because security is one thing that is very personalized. Every network that you go to will have its own policy that might be different from other policies. So I would not want to do a cookie cutter with what do you call it, security. Cookie cutter basically means I have one set of rules that I apply to multiple different locations. I would not do that. Then, oops, we go to the other part of the class. That is your wireless. Yes, we can. StealthWatch is not covered over here, but everything else, ICE is, FTD is, ESA, WSA, all of that is covered over here. But yes, all these can now be integrated into one infrastructure of security, which gives you a complete security rather than just a individualized boxes. They all integrate with each other. Now, in terms of wireless, you would need to know how to initialize your WLC. Bring it up from scratch, configure the switches to set up your wired network and how it integrates with your wireless network. We'll initialize the WLC. Very basic. We're not doing a CCIE wireless over here, but at least getting you acquainted with the wireless network, because you would need to integrate WLCs with your ICE later on in this course. Also, setting up basic security on the WLC, like your the web authentication, that type of stuff. Later on, we'll integrate the WLC with ICE as well, which is coming up in the next section. But at this point in basic wireless LAN configuration, I want you guys to get a WLC up and running so that you know how a WLC works with Cisco. Once that's done, then we go into the ICE portion. In ICE, we're doing a lot of different things. First of all, we're doing wired ICE, where we set up a relationship between the switch, which is your wired device, and you're doing ICE integration with it. No, we're not covering security management appliance over here. A lot of stuff to be covered over here. So whatever I can, I will try to do, but it's generally a lot of stuff over here. Wired ICE, relationship between the switch and ICE, configuring identity groups and users. Those are your basic users. When users log in, you'll create a username, password database over here. Although there's integration with AD, Active Directory, that is also possible. Here on the exam, they try to stay away from it. So you'll be creating the users and groups locally. We'll take a look at how to do dynamic VLAN assignment. So when a user logs in, based on his username, password, the switch port will be assigned to a particular VLAN. Not only that, you will also be able to download an ACL. The DACL, D stands for downloadable ACL. The ACL will be downloaded for that particular port while the user is logged in. As soon as the user logs off, the ACL will go away from the port. New user logs in, a new ACL will be downloaded to that same port. So you have the ability to do per user ACLs using ICE. Configuring MAB, which stands for MAC-based authentication bypass, where you do authentication for devices that do not support .1x. You do it based on their MAC addresses. For example, printers. You want printers to be connected to a particular port. You basically say that this port needs to have MAB. MAB, you take the MAC address from that particular printer and store it inside your ICE database, saying this MAC address is allowed to come into my network. That stands for MAC-based authentication bypass. IP phone is another example of that, absolutely. So in this example, we're not going to do a printer, we'll do an IP phone. And behind the IP phone, you'll have a PC, which will do .1x authentication for normal .1x. As I said earlier on, I also intend to integrate wireless, the WLC with ICE. So rather than doing your normal web authentication that you do with a 5-character or a 13-character web password, I want the ICE to do the username password authentication. So the user will be assigned a VLAN and a DACO from where? From ICE. So the user will be authenticated based on ICE. All right, you'll be doing that as well over here. So the integration between ICE and the WLC will also be demonstrated over here. Now, besides that, I will also be doing SXP. Anybody heard about that? The SXP, it's a protocol. The purpose of SXP is to provide more dynamic, how should I say it? A dynamic relationship between the different security devices. TrustSec, yes. It allows you the ability to, for example, let's say a user logs in to a wireless setup. So in the wireless setup, you have the WLC, which integrates with your AP. The user is logging in from here. He gets logged in. He gets an IP address from the DHCP server. Now you have a firewall over here. That's an ASA firewall going to the internet. You want certain users to be able to go to the internet, certain users not to be able to go to the internet. All right? How do you set that up? One of the things that you can do is when the user logs in, he gets an IP address from the DHCP server and then registers that to the WLC. The WLC has the ability to send that information across to ICE by using these tags known as security group tags, which are just numbers, SGTs. These are nothing but numbers. Let's say number 5,000. So if a user from the sales department comes in conjunction between the WLC and ICE, they set up a protocol called the SGT exchange protocol. That's what SXP stands for. So they exchange that group tag and the IP address information between what? The WLC and ICE. So now ICE has identified that a particular user logging in from sales will have a group tag of what? 5,000. It tells the WLC to assign that particular user a security tag of 5,000. Now, based on that, you have the ability to go on the firewall and create a special ACL. It's the same ACL, but special entries inside the ACL based on what? SGTs. You can create an ACL and have it in place saying if a particular user comes in based on a particular SGT, let's say 5,000, he should be allowed access to these websites or these networks on my firewall and not allow access to other parts of the network. So it uses tags to define access. This is part of the Cisco TrustSec architecture. Unfortunately not. We won't be going into the PX grid because it will take a lot of time to do that. But I'll give you an overview of where PX grid comes in with the SGTs. But in terms of the integration of SGTs, we will be doing that because now I'm going to write an ACL based on the SGT on the firewall. I'm going to be configuring a relationship between the firewall and WLC based on the SXP. But in terms of the PX grid, I'll give you an idea of what it is. All right, this is also covered in the class as part of the SGT over here. That's what this is all about. Configuring the SXP protocol between ICE, WLC, and firewall to implement filtering using SGTs. And that exchange of the SGTs is done based on the SXP protocol, the SGT exchange protocol. The firewall runs it, the WLC runs it, and ICE runs it. All right. And the last part over here, this is something that used to be done based on the ACS, because in the older version of ICE, in 1.x, you do not have the capability of running TACACS Plus. 1.x lacked TACACS Plus capabilities, the ACS does. No, sorry, ACS did. Now ICE 2.x also does. Although the ACS is on the blueprint, I don't plan on covering it. I don't think it's going to be on the exam because it's already end of life. But I do have videos. If you want, I'll give you the videos from my 4.x security and you can take a look at it. I would not spend too much time on it because they have integrated those type of things into what? ICE 2.x. So I'll show you how to do the same administration stuff that I did on ACS on ICE 2.x for the device administration part of it. All three, authentication, authorization, as well as accounting for the network devices. This in the older version used to be done based on the ACS product. It's still on your blueprint, but I don't think they're planning on putting it there. It's already end of life. All right, clear? I'll give you a video for that, for ACS. And then the last part, router and switch security. What is that? Different features that are security related on your routers as well as on your switches. Features like NTP, unicast reverse path forwarding, URPF checks, DHCP server and DHCP relay agent. How do you set that up? Syslogging. How do you set different messages to your syslog server? We'll take a look at that. And then on the switch side, port security, DHCP snooping, ARP inspection, source card, VLAN ACL. That's not on one, this is an ACL. This is how do you create VLAN maps, VLAN ACLs on a switch. All this stuff will be covered in this particular class. This is a class that is not just meant to help you pass the exam. If you're in the security field, this is the future. The next couple of years, quicker you get acquainted with FTD, the better off you are. You are going to get the first movers advantage over there because a lot of people are not aware of what FTD is all about. I was teaching a class at Cisco Advanced Services, Bangalore, a couple of weeks ago. They are overloaded with requests to replace checkpoint firewalls with FTD. So this is advanced services. This is only the tip of the iceberg because the people that go to advanced services are people that can afford them. Because they're very expensive compared to like a partner. If you go to a, like, let's say you go to a gold partner and have them configure your devices or do a migration project versus having the advanced services do it, the price difference is almost double. But people are still going to advanced services doing what? The migrations because they're not confident. The partners are not confident with the FTD right now. And Cisco doesn't want them to mess it up. This is advanced services in Bangalore, although it's a global distribution center for them. So they are not just handling India, they're also handling the Asia Pacific region and also a part of the Middle East. Just to give you a heads up on that. Loads of migration work, absolutely, from not just from other vendors, but also from ASA towards your FTD. You'll see a lot of work in that space as well. ASA to FTD migration will be a huge thing in the next 2 years. So from that perspective, this is a very valuable class. All right, any questions, guys? This is what I'll be covering in this particular class. This is the outline of the class. I've sent this outline to you guys in the past as well, but I also wanted to give you guys an overview of what the whole class is going to cover. Any questions so far? How many times have I covered this session? About 6-7 times, man. No, but I did the boot camps as well. Remember those ones? That's just 3 times you're talking about is just the what do you call it? The package program. But I also do the boot camps. I've done 3 boot camps, 2 of them for Cisco Advanced Services. So 6-7 times now. The good thing is, not a lot of people are doing it right now. In terms of CCIE security. So that gives you another advantage because when you go out there, you won't have a lot of people that will be competition for you. Yeah, man. How many times have you taken it, Conrad? This is number 2. Okay. All right. If no questions, let's take a short break. When we come back, we'll take a look at, we'll start doing the VPN portion today. Good. If everybody's good, take a look at the clock. I want you guys to use this as a reference clock over here. So let's say it's 6:35 based on this. Take 15 minutes from that. Just adjust your clocks to whatever time you're in. So we'll say 6:35 over here till 6:50. 15 minutes later, we'll get into the course. We'll actually start doing the VPNs today. No wasting time. A lot of stuff to be covered. Good. I'm going to mute it for 15 minutes. We'll come back and we'll pick it up from here. Hey guys, everybody back? All right, so VPNs. First thing I want you guys to understand is what a VPN is. A VPN allows you to connect two private networks to each other. Let's say I have a private network over here and another private network over here. The objective of a VPN is to connect them over a public network to each other. Does it require encryption? The answer is no. VPN does not require encryption. This is the definition of a VPN, connecting two privates over a public network. You guys know about frame relay, right? Layer 2 technology or Q&Q tunneling, layer 2 technology, all are VPNs. But these type of VPNs are known as L2 VPNs, layer 2 VPNs. They're also connecting what? Your private network to a private network over a public network. The public is your service provider network. Or for that matter, you might have also heard about MPLS VPNs. VPNs connecting two private networks over a public network. The public over here is your service provider. So the definition of a VPN is what? Private to private. These type of VPNs do not require any encryption. Still a VPN. Tunnel, I wouldn't call it a tunnel because you have policy-based as well, Manik. So that is policy-based VPNs. So don't get caught up on the concept of a tunnel. So connecting these two sites to each other is a VPN. No encryption. But the ones that we'll be focusing on over here are not your layer 2 VPNs or MPLS VPNs. Our focus in this particular class is going to be on L3 VPNs. The difference between the different type of VPNs is what type of connection are they providing. In a layer 2 VPN, these two sites are connected to each other by using some type of layer 2 forwarding mechanism. In case of frame relay, the forwarding mechanism in the provider cloud is a DELC. In case of ATM, which is another layer 2 technology, the forwarding mechanism is a number known as VPI, VCI. In case of a Q&Q tunnel, which is another layer 2 VPN mechanism, the forwarding mechanism is a VLAN tag. That's what makes it a layer 2 VPN, because the forwarding mechanism is a layer 2 mechanism. In case of an MPLS VPN, the forwarding mechanism over here is a label. Multi-protocol label switching. Label is your forwarding mechanism. In layer 3 VPN, the forwarding mechanism is an IP address. Generally, in a layer 3 VPN, you have an outer header and an inner header, which is encapsulation. Here in a layer 2 VPN, I'll just use one example. I'll use an example of a frame relay setup. The encapsulation on the layer 3 side, you would have, let's say, 10.1. communicating to 10.2. All right? And then over here, you would have the del C number. This would be the del C. The forwarding in the cloud would be done based on the del C. They would not look at the IP address to forward the traffic. So the service provider would only look at what? The del C number to forward it. They don't care about the IP header. Then you have an MPLS VPN. In there, you would also have, let's say, 10.1 going to 10.2. But the forwarding mechanism over there would be a label. Let's say the number over here is 211, just a number, a label number. Again, the service provider will not be forwarding based on this IP address. They will be forwarding based on the label. So whatever the service provider is using to forward, that's the classification of the VPN. This is a layer 2 VPN because del C is a layer 2 header. This is an MPLS VPN because the forwarding is done based on a label. And that is why it's called an MPLS VPN. In a layer 3 VPN, you have an outer header, generally a public address, let's say 199.111, going to a public address. This is the two public addresses of the public routers, and inside is your because my forwarding now is done based on what? The service provider will be forwarding packets based on what? The IP addresses, which is a layer 3 header. Based on encapsulation, it is called a layer 3 VPN. Our focus is going to be on this type of VPN. I just want you guys to understand the difference between an L2 VPN, an MPLS VPN, and a layer 3 VPN. All these VPNs that I showed you over here are examples of L3 VPNs. Means it's going to have an outer header and an inside header to forward traffic. Both are going to be IP addresses. Outer header, IP, inner header, IP. Outer header IP is the one that is understood by the service provider. Inner header is only understood by the end devices, the clients. Good so far? You guys okay with that? Any questions? Everybody okay? Yeses, please. That's the only way I know if you're okay with it. It's an IP and IP tunnel, absolutely. So that's the first thing I wanted to get out of the way is understanding the different type of VPNs, because all of them are called VPNs. And one of the things that you need to understand, encryption is not a must. It's recommended to do it. It's not required to be done. So my first type of VPN that we'll be taking a look at over here is your LAN-to-LAN IPsec VPN. IPsec is a protocol that allows you the ability to set up a VPN. In our example over here, we're predominantly going to be using IPsec as the VPN protocol. We'll also be using GRE to a lesser extent. But the predominant protocol that we'll be using for VPNs is IPsec. As we go through today's lecture, you will understand why is IPsec more preferred or is preferred over GRE as a VPN tunnel. We'll take a look at that. So I'm going to start off by taking a look at how to set up a basic IPsec tunnel and what are the characteristics that you need to be aware of. All right. So IPsec is my first type of VPN that I'm going to be doing. I'm going to focus on a LAN-to-LAN IPsec VPN. But before we do that, let's understand encryption, because encryption, although it's not a required thing, is a good thing to do. Let's say I'm connecting two entities to each other. I'm connecting, I'll explain that. I'm connecting router 1 to router 2. I'm connecting my 10.1.1.0 network, private, to 10.2.2.0 network, public. This is the internet. The ISP will assign me some public address that will be assigned to my outside address or outside interface. Let's say that address over here happens to be 199.1.1.1. This guy got his public IP from his ISP. These two devices could be anywhere in the world. As long as they have IP addresses connected on the internet, they have reachability to each other. I can set up a VPN between them. I want to connect my 10.1 network to my 10.2 network. This is my LAN. This is another LAN. So LAN to LAN VPN. One way of classifying it. One way of saying it's a VPN. My objective is to connect LAN on the left side, which is 10.1.1.0 to 10.2.2.0, LAN to LAN. Also called site to site. You can also, based on the protocol that you use, you can call it the IPsec VPN. There's different ways to classify it. Now, when I'm sending traffic from router 1 to router 2, I'm going through the internet. So the service provider over here will have access to my data, can see my data. Certain type of layer 3 VPNs like GRE, although I am encapsulating the packet, I will not be encrypting it. So they have access to my data. So if they want to sniff the packet and see what's inside it, they do have the ability to do that. That's where encryption comes in. Encryption allows you to scramble your data, make it into a format that cannot be read by the people in the middle. All right? So what is encryption? Let's take a look at a very simple form of encryption. I want to encrypt data from R1 to R2. Okay? A equals 1, B equals 2, C equals 3, D equals 4, E equals 5. A equals 1, B equals 2, C equals 3, D equals 4, E equals 5. That's a key. Both sides have it. They pre-settle on this. They talk to each other. They say, this is what I'm going to be using as a key. Okay? If I want to send some data from R1 to R2, I can send the data. Let's say I want to send the word feed. Let's put F over here as well. How would I send feed? 6554. Sanjay, put your question to everyone, not private. And I'll answer it after I'm done with this lecture over here. So you guys understand that this is encryption. Very simple form of it, but it's encryption. To him, in the middle, he sees 65554. But when the other guy gets it, he knows 6 is what? F, 5 is E, 5 is E, and D is 4. But the thing about that is if the guy in the middle over here that wants to get to your data gets enough of this data, he has the ability to run what is known as the brute force dictionary attack. What that does is it collects a lot of data, and based on that, it can run it, and where it checks each and every character in a sequence, a computer does that, trying to figure out which combinations gives me a valid dictionary word. I'll get to what the key exchange process is. Here, I didn't exchange the key. I manually set the key on both sides. So a valid dictionary word will only be helpful to me if I have a lot of data where I can compare. By just looking at 6554, it could be anything. But if I have a lot of transfers taken place, a lot of data that has been transferred from R1 to R2, the person in the middle can keep on trying to figure out the data, and based on that, it will figure out, oh, this is the key. Every time he uses the number 6, it corresponds to a valid word in the dictionary, and that 6 means F. So how do I crack into this encryption mechanism? Is by gathering a lot of data. Do you understand that? So the base foundation of cracking your encrypted data is collecting a lot of data, running it through what? The brute force dictionary attack, figuring out what each character means. And once I have the key, I can decrypt all the data. But in order to do that, I need to collect a lot of data. Good? So in this case, if I use the same key to encrypt, it's not going to be helpful because eventually the data will be cracked. So how do I get around that? What should I do so that he does not collect a lot of data with the same key? So to counter this, I would need to do what? Change my key. Change my key to what? Change my key on a regular basis to something different. All right? So if I keep on changing this key and this key is not the same, the person might collect a lot of data, but the keys are different. The next time round, I'll say my key is this. I'm just giving you a very primitive example, but something that you can actually understand and relate to. In reality, these are algorithms, which are sophisticated numbers that are derived. But over here, for you to understand it, if I keep on changing the key, what's going to happen? If I keep on changing the key, even if they collect the data, they don't have the right numbers. In the older data, A was 1. In here, it's 51. So the brute force attack would fail. You understood? So what's the key of protecting your data? How do you protect your data? The way you protect your data is by changing the key on a regular basis. The other side, it has to be the same key on both sides. Agreed? So it's a cumbersome process. So somebody needs to sit and do what? Change the key on both sides on a regular basis. You understand that? But it is something that is very important and required to set up a secure communication. My whole purpose over here was to encrypt. So if I really want security over here, I need to have what? I have to change my key on a frequent basis. How frequent is frequent? Depends on the encryption level that you have. But generally 1 hour. Every hour you should change a key. Now, when you change your key, when I'm talking about changing your key, what do I mean? I need to go in and manually set the new key. It's not something that you want to have a dedicated person sit and do it every hour. So what they did was they created a protocol, a mechanism that is there to generate this key. The purpose of this mechanism is to generate a key that will be used for encrypting the data. This was done by two guys, Diffie and Hellman. So they came up with an algorithm for doing what? Generating the key. But they would generate it individually over here. So he would generate his key, he would generate his key. In order for it to work, both guys would have to have the same key. Otherwise, if I'm encrypting something, he does not have the key, he would not be able to figure that out. So Diffie-Hellman was used to do what? Generate the key on both sides. But now the second problem came in. If I generate the key, I need to send it to whom? To the other guy to do what? Encrypt and decrypt. If I send this key in the clear and it gets compromised, guess what? The rest of it is compromised. So I need to send this in a secure tunnel, secure mechanism. So I set up a secure mechanism between what? Two entities to exchange what? This data encryption key, or this key for secure communications. In order to do that, I need to have a secure transfer between what? R1 and R2, two devices. In order to secure any type of tunnel, I need three entities or three components: a key, an encryption algorithm that I'm going to be using, and a hashing algorithm. What are these two? Encryption is what I just told you, scrambling the data. Hashing is a mechanism which allows me the ability to create a checksum, a very sophisticated checksum that checks to see if the data has been tampered with in transit. If somebody changes the data, I will find out, oh, this data does not have the proper checksum. Means drop it. So I'll set up a tunnel between what? The two devices, setting up a key, encryption, and a hash which matches to send the data. What is my data over here? What is going and getting sent across from one side to the other? This Diffie-Hellman key. It's actually not even the key, it's certain numbers, but for your understanding for right now, my objective of setting this tunnel up is to exchange what? The key. That can be used then to encrypt your data. But as I said, there needs to be a key for every tunnel. Encryption is DES, triple DES, hash is MD5 or SHA. Encryption, you also have AES. We'll get into the mechanisms later on, but understand this for right now. So you need a key, you need an encryption, and you need a hash to set up a secure communication channel between the two entities. How about the key for this tunnel? I'm saying I need a key. For this tunnel, the first tunnel, there's different ways to do it, but for right now, I'm going to set up a pre-shared key. Pre-shared key. Pre-shared means I'll agree upon a key like a password. Let's say Cisco 123. The Cisco 123 is a password that will be used for the trigger for my key. It'll be my key, which will be used to encrypt and hash my communication that happens between the two entities. What's the only thing that I'm sending over here on this particular secure communication channel? The key that will be used for my data. So my first tunnel, I'm still setting up a static key. Like I showed you, which is not as secure. I'm using that mechanism for this. But the thing over here is I'm not going to send any data. What was the key? The key to crack a key. What did I need to crack the key? Do you guys remember? What did I need to have to crack a key? Anybody? A lot of data, right? I'm not sending any data over here. What am I sending? I'm just sending the session key itself, the key itself. That will be used for data encryption. So it's not a lot of data. Having said that, there's better ways of doing it, but that we'll take a look at later on. So at this end, I have set up what? What have I exchanged over the secure tunnel? The key. The dynamically generated key. Who dynamically generated the key? Diffie-Hellman did. Right? So the key is over here. Now I'm ready to do what? My encryption of my data. So I'll set up a second tunnel over here. For the first key, this key, it could be a certificate. Got it, Sinan? For the first key, it could be a certificate base. It's not a certificate. It's inside the certificate, you have a public key. So it's still a key, but it's a public key. Certificate is just the holder of the public key. For the first one though. Second one, no. Second one is done through Diffie-Hellman, exchanged through this first tunnel. What did I tell you I need for a secure communication channel between the two endpoints in a tunnel? What do I need? A key. What else? It's still there on your screen. Every tunnel requires what? Encryption and a hash. So for my second tunnel, again, I need to set up my parameters, encryption and hash. I don't need to set the key over here. Why? That's the whole purpose of the first tunnel, is to exchange what? My key. All I need to set up over here is what? My encryption and a hash mechanism that needs to match on the second tunnel. And what gets encrypted over here? What gets sent over here? Data. Encrypted using this dynamically generated key, which was generated by Diffie-Hellman, exchanged in the first phase, used to encrypt the second tunnel. The good thing about Diffie-Hellman, the lifetime of this key is 3,600 seconds. 3,600 seconds is 1 hour. After 1 hour, what's going to happen? This key will expire automatically. Diffie-Hellman will generate a new key, exchange it over here. He will get a new key after 1 hour, key 2. You didn't need to do it. It did it automatically, dynamically. So every hour, your, what do you call it? Your Diffie-Hellman will wake up, generate a new key, exchange the new key, go back to sleep. This transport is not TCP, right? Depends on what protocol, what tunnel. We'll talk about the protocols in a second. You guys understand the concept? So let's recap that, and then we'll go into nitty-gritties over here. How many tunnels do I need? 2. The first tunnel. What's the objective of this secure communication channel? What's the purpose of it? Purpose is exchange the key. Agreed? In order to set the secure channel, what 3 parameters do I need to secure this channel? A key, an encryption mechanism, and a hash mechanism, which needs to match on the other side. Good so far. Once this secure channel is established, I also need to set up what? My Diffie-Hellman mechanism to generate my key, the data key. In Diffie-Hellman, you have 3 mechanisms. You can generate a key, which nowadays it's more than 3, but just as a basic, you have 3 mechanisms, which is called group 1, which generates a key size of 768-bit. It's a key that is quick to encrypt, but not as secure. Then you have another key that you can generate in Diffie-Hellman called 1024, which is more secure than group 1, but it takes more time to encrypt and decrypt. And then you have group 5, which is 1536, which takes more time to encrypt, but is more secure. So you set whichever preference you want. Based on that, you set up the key that you want to generate. Let's stick to the middle. We'll say we'll generate a key size of what? 1024. Who does that? Diffie-Hellman does that. You need to match that on both sides. This is group 2. So to set the secure tunnel, I need a key, which in our case, we're going to do a pre-shared key. Means what? I'm going to manually set the key on both sides. An encryption mechanism, DES, triple DES, AES, whatever you want to set up. Hash mechanism to make sure it's not tampered with. SHA-MD5. I do that. My tunnel is secured. Now the purpose of the tunnel was to exchange the key, generate and exchange the key. That is done by Diffie-Hellman. What gets exchanged? The Diffie-Hellman key gets exchanged. That sets me up for what? My second tunnel. What's in the second tunnel? I again need the 3 parameters. Key, what else? Encryption and hash. But the thing about the second tunnel is I already have what? What do I already have at this point? I have the key. That was the whole purpose of what? The first tunnel. So all I need to configure over here is what? The encryption mechanism and the hash mechanism. The data that will go across over here will be encrypted by using what? The Diffie-Hellman key. You understand that? Everybody okay with this? There are unidirectional tunnels, yes. Means tunnel, one tunnel from A to B, another tunnel from B to A. Now, the thing that you need to understand over here are the protocols that are used to set this up. The protocol to exchange this information from what? A to B and B to A is a protocol by the name of ISACamp, which is a UDP-based protocol, port number 500. This tunnel, the first tunnel, is called the phase 1 tunnel. Coming back to your question, Sinan, what's a transport for the first tunnel? It is a UDP-based transport. based on port number 500. It is not TCP based. So your transport is UDP in that case. Phase 1. Phase 2 is done by its own protocol. It's not even dependent on TCP UDP. It's an IP protocol by the name of ESP, which is protocol number 50, not port number. That is used to set up my second tunnel. This is also known as phase 2. So what's the purpose of phase 1? To exchange the key that will be used for data encryption. This key, the key that will be used for data encryption, has different names. It can be called the session key. It is also known as the traffic encryption key. TEC. So what are the names for this Diffie-Hellman key? It's called either the session key or the traffic encryption key, TEC. The first one, the one that you use to encrypt what? Your session key or your traffic encryption key, is known as the KEK, key encryption key. Because it's used to encrypt what? The key. Or it can also be called the pre-shared key. Does that make sense, guys? Everybody okay with this? Which part, Ahmed? KEK is your encryption key to encrypt. See, every tunnel, any tunnel that you have, what's a requirement to set up a tunnel? You need to have a key to encrypt so you can scramble the data. You need the encryption mechanism and a hash mechanism. So the data that goes across, in case of the first tunnel, it's not really data, it's what? It's the session key that needs to be transported. So I need to have a mechanism of encrypting what? This key. So in reality, it's not really data. What is it? It's a session key. How do I encrypt this session key so it gets to the other side in a secure manner? I need to have a key to encrypt this key, right? That is this key. That is the one that is called the pre-shared key. The pre-shared key is also known as the key, because it's encrypting this, key encrypting key. KEK. Makes sense. The purpose of the pre-shared key is to encrypt the session key. Once the key is on the other side, which key? Once the session key is on the other side, now I'm ready for data. DH is basically for phase 2 for data encryption. DH is used to generate the session key, which is used in phase 2 for data encryption. Absolutely correct. Although DH is being used in what? In phase 1, but its purpose is not for phase 1. Its purpose is for phase 2. It is setting up phase 2. Ahmed, you good with this? Now you would have your encryption and hash over here. So you have ISACEMP over here, and you have ESP over here as the two protocols. Pre-shared key is never sent, it's used. Pre-shared key is something that I manually, pre-shared means I set it up manually, right? So I set the same key on both sides. Because I'm setting it on both sides, guess what? They agree upon that. So they never send it across. They use it to encrypt your session key. Good? So that's phase one and phase two. If it is compromised, you have the danger of losing all your security, because if that's compromised, then guess what? Which one is compromised? The pre-shared key? That means any traffic that will be encrypted from that key can potentially get compromised. So you want to safeguard it. Because if you compromise the pre-shared key and somebody is sitting in the middle and they know it, they can basically use that to find out the session key every time it gets transmitted. Now there's a more secure way of doing it using certificates. We'll talk about that later. But before I go on there, I also want you guys to understand that I talked about two phases, right? Phase one, which is done based on what protocol? ISACEMP. And phase two, which is done based on ESP. Everybody agree with that? You guys understand that? Now, what's the purpose of phase one? What's the purpose of phase one? Both sides generate the key, Surya. Key exchange, right? Now, is there a possibility, can I go to my routers or my devices, my encrypting devices, and say, forget about phase one, I'm going to do a manual session key? So in IPsec, what I'm saying is, do you have the ability to directly go to phase two by setting the session key manually? Because if I'm setting my session key manually, I don't need phase one, do I? I'm not saying it's a good thing to do. It's a very bad thing to do. But can I do it? Think about it. Can I have phase two without having phase one? Actually, you can. It's not recommended. Actually, you can. How many people have done a LAN-to-LAN VPN over here? You have? How do you, what do you apply to your interface when you're doing a LAN-to-LAN VPN, guys? Remember the commands? You apply what to the interface? Crypto map. Right, everybody? Okay, now when you create the crypto map, how do you create the crypto map? Do you remember the syntax? ISACEMP policy is not your crypto map. That's an ISACEMP policy. You say what? Crypto map ABC, whatever you want to call it, and then do I end it like that, or do I say something after that? No, but what does a crypto map, the full command of the crypto map say? It says crypto map ABC 10. And if you remember, it says IPsec ISACEMP, like this. You guys are seeing my chat window? Right? What does IPsec ISACAMP do? It says, this is the command that says, get your session key from ISACAMP. Have you done that command before? Blindly? Now, let me tell you the other way you could have done it. I'm not saying you should have done it. There's an option called manual. When you say CryptoMap ABC10 IPsec manual, you're basically telling your router, I am not going to use ISACAMP for phase 1 or generating my session key. I want to do it manually. So now you need to set the session key manually under CryptoMap. I'm not saying it's recommended, but understand what it does, how you link your CryptoMap to tell it, get the key from phase 1. So yes, you could potentially, technically, do ISACAMP, do IPsec without using ISACAMP. Some of the devices don't even support it, but the routers do. The firewall does not support it. The firewall says only do it through ISACAMP. You don't even have a choice. But on the routers, you do have a choice of doing it manually. It's not recommended, but I want you guys to understand the flow, the purpose of phase 1 and phase 2. This is for the people that have done it in the past. If you haven't done it, you don't understand it, don't worry about it. You will see that command coming up. Good so far. Now, what do I need to set up a tunnel? A key, encryption, and a hash. For phase 1, I need to also define my Diffie-Hellman. Right? How about phase 2? What do I need to define? What do I, as a engineer, need to define? Just the encryption and the hash. I don't need to define what? Key, because the whole purpose of phase 1 was to encrypt, create the key. Good? Let's take a look at it. Let's do this now. So I want to configure a VPN between A and B, router 1 and router 2. Step 1, configure the parameters for phase 1. The commands to do it on a router: crypto, ISACAMP policy, and a sequence number, because you can have different policies. I might be setting up different tunnels for different entities on the internet. So let me do it like this. Router 1, connected to router 2, connected to router 3, and connected to router 4. I want to set up a tunnel between R1 and R2, and they have agreed, R1 and R2 have agreed that they want to use the encryption mechanism as triple des. The hash that R2 insists on using is MD5, and the Diffie-Hellman group that they want to use is a 1024 key. So these are the parameters that I have agreed upon. With whom? R2. But at the same time, I'm also doing a tunnel with whom? R1 to R3. He insists that he wants to do encryption based on triple des, but his hash has to be SHA, which is another hashing mechanism. And the group, I don't care, has to be 2. Can I use the same policy for both? No, because they are different. So I need to define both the policies. This is just a sequence number, like a priority number. Because when I configure both of them, I'll send both to both. they can pick which one matches their own. The number over here is the lower number. So it'll try to match the 10 before it matches, let's say, a 20. So the number is nothing more than a sequence number of creating these parameters. So for example, on R1, I might do what? I might say authentication I want to use is pre-shared keys. Means I'm going to set up the password. My encryption is triple des. My hash is MD5. My group is 2. And the second one, for the second guy, is almost the same, but a difference, right? So I'm creating different what? Different profiles for what? Different guys. I'm going to send both of them to both. And it's up to them which one they want to check first. You guys understand that? So it's not specific to a particular entity. I'm going to send both of them my parameters. They need to check which one they want to match. And as long as one of the policies on the other side matches, it's good for phase 1. But at the same time, I also need to set, because I said what? That my key is what? Pre-shared. Pre-shared means what? Set it. Pre-share. So manually set it. I need to agree upon this. I'll say ISACM key for the first guy is Cisco 111. This is for the address that I'm communicating. Let's say 192. I'll say 20.2. ISACM key is Cisco 222 for 30.3. So these are two different endpoints. These addresses are the public addresses of my peer routers on the other side. Everybody okay with this? Yeses, please. If you don't understand it, let me know. I'll explain each one to you. So at this point, once this tunnel is established, based on either policy 10 or policy 20, what's the end result? I have a secure tunnel established for exchanging my key, which is generated by Diffie-Hellman. Cisco 111 is the pre-shared key, absolutely. Over here, I said I want to use a pre-shared key, and this is where I'm defining the actual key for the peer. This is the public address of the other guy. Good? So what's the end result of this? Yes, there is a possibility of not using a pre-shared key. That's where I use the PKI infrastructure, public key infrastructure, which is the certificate-based. We'll also do that later on, which is a much better way of doing it than doing this one. But for right now, just do pre-shared keys. Not as secure, but easy to set up. What's the end result? What do I get out of this? I get the session key for my second phase. Absolutely correct. Now, what do I need to do in my second phase? What are the parameters that I need for my second phase? Encryption and hash. Step 2, configure the parameters for phase 2. The command for that, crypto, IPsec transform-set. You give the transform set a name. Let's call it T-set, transform set, just a name. But in there, I say I want to use ESP. Let's say triple des as my encryption, and my hash is ESP, let's say MD5. Group is responsible for the key. Group is responsible for generating the session key that will be used in phase 2. Does that answer your question, Sanjay? So group 2 is the one that will actually generate the key for that will be used in phase 2. So what am I saying over here? For phase 2, I'm going to use triple as my encryption and MD5 as my hash. I don't need the key because the key is what I derived from phase 1. So my 2 tunnels are established at this point. These 2 steps that I gave you guys over here for phase 1 and phase 2, regardless of what type of VPN you're doing, whether I do LAN to LAN, whether I do GRE IPsec together, whether I do SVTI, DMVPN, GetVPN, any of these VPNs, I will have phase 1 and phase 2. So this is the foundation of IPsec on all the different type of VPNs that you're going to do. You're going to have phase 1 and phase 2. Everything stems from phase 1 and phase 2. And what's the purpose of phase 1? Exchange the session key, also known as the traffic encryption key. And phase 1 is used to do that. Good so far. You guys understand every single command over here, the purpose of each command over here. I don't want you guys just doing the command sets just without understanding what you're doing. I want you guys to understand if I don't put a particular parameter, what's the effect of it? Again, somebody else asked that same question. It's never sent. It's pre-shared, so both can figure it on their own side. It needs to match. When the phase 1 proposal sent, is it sent in the clear? The proposals, yeah, it's not, because you have the key that you already have the key at that point. But proposals is not important over here. The actual thing is the tunnel, the first tunnel, the session key should not be sent in the clear. The proposal is not that important. It's just specifying which one am I using. Now, I'm ready with the 2 tunnels. I need to next set up what traffic do I need to encrypt. So I have 2 routers. Let's say I have 10.1.1.0 over here, and I have 10.11.11.0 over here. This is the internet. This is router 2. I have 10.2.2.0 over here, and I have 10, let's say 22.22.0 over here. How do the transform set know which session key to use? I'll get to that. Give me a second, we'll get to that. So you have 10.22.22.0, 10.2.2.0. Now the next thing I need to specify to my tunnel is I have an established tunnel. Phase 1 was done, and then a phase 2 was done. The next thing is to specify over phase 2 what traffic should be encrypted and decrypted. That is called the interesting traffic. Defined by the crypto ACL. So over here, I'm going to say I want to encrypt traffic from what? 10.1.1.0. Let's say I just want encryption of 10.1 to 10.2. I don't want encryption of 10.11 to 10.22. I want to keep them separate. So I only want to encrypt what? This traffic to that traffic. This is known as the interesting traffic ACL, crypto ACL, encryption ACL, different words for it, basically defining what traffic will go over the tunnel. How do I define it? A normal ACL. So that's my Third step, define the traffic that will be encrypted over the tunnel. All right, how do I do it? Normal ACL. Permit IP 10.1.1.0 to 10.2.2.0. Good so far? So you have phase one, you have phase one parameters, you have phase two parameters, you have your interesting traffic ACL. Rinchen asked a question earlier on. How does it know which tunnel to, which session key to use if I have multiple session keys? How does it know which transform set to use? I need to link up what traffic is used for what. These are independent configurations right now. It's just an ACL. It's just a transform set. I need to link them up. And that's what is done in a crypto map. Use or configure a crypto map to link the above parameters to each other. That's the whole purpose of the crypto map. Crypto map, and give it a name, whatever you want to call it. Let's call it C map, just a name. Sequence number 5, because you're going to have multiple crypto maps. IPsec, ISACM. That basically tells it, hey, listen, I want to get my session key from the top. Do you remember I have 2 tunnels? Remember, I've been going through that every time. How many tunnels do I have? 2. I have a key, encryption, and a hash over here, which is your for the ISACM tunnel. This is my second tunnel. I have my key, encryption, and a hash. They're independent of each other. So the encryption and a hash that I defined in ISACM is only for what? The first tunnel. The transform set is for my second tunnel. Remember, I have 2 tunnels, right, Deepti? Absolutely. I don't need the key for the second tunnel. Why? Because I'm doing it through phase 1. So I only need encryption and hash for the second one. This is done through the transform set. This is the phase 1 that I defined in the ISACM policy. Do you get it? Should I move on? So now when I say this, I'm telling it, get the session key from where? From phase 1. What was the other option that I was talking about? If I don't want to use phase 1, I can also do manual. What's the drawback of that? If I do manual, that means I need to set the session key manually. That means all the data is going to be used or encrypted using the same session key. If I send a lot of data using the same session key, it has a high chance of getting compromised. So that's why I generally don't even see this option, but I'll show you it's there. I use ISACM, get the key from Diffie-Hellman. So that's where it goes and sends all my policies to the other device saying what? These are my policies. Let's set up phase 1. So once that tunnel is established, then it goes ahead and starts doing the procedure. Now, what traffic do I need to encrypt over here? That is done by the match address command. I'll say if traffic 101 comes in, I want to set up a tunnel towards whom? Towards this. That's the linking of the 2. So now what have I linked over here? I basically said if this traffic comes in, which is what? 10.1 to 10.2, that traffic needs to be sent to whom? To 20.2. But I need to get the key from where? ISACEM. So it goes over here, starts a tunnel towards 20.2, uses this as my key. Establishes phase 1 based on what? Key, encryption, and hash. Once phase 1 is established, it will do the Diffie-Hellman, generate the key, and exchange the session key. Once it's done, what's the end result? The end result would be your session key is generated, but I still need what? Generate an exchange. I still need an encryption and a hash. So this thing would have already gotten your session key. What's the next thing that I need to do? I need to set my encryption and hash for second phase. Set transform set. What did I call it? T-set. So for this traffic, I would have a session key, and this is the transform set for that. Rinchan, does that answer your question from earlier on? So that session key that was generated based on this session will be used for this particular one with this particular transform set. Similarly, let's say I'm going to what? The other router, router 3. That would be different traffic, right? It would be 102, for example, permit IP 10.1.1.0 going towards a network behind him, which is different, right? Router 3 will be a different site, will have different addresses. Now for this guy, what would I do? Crypto map, the same crypto map, because I can only apply one crypto map on an interface. So I'll say 10, different sequence number. Match address what? 102, set the peer as 30.3. If I want, I can use a different transform set with him, or I can use the same one. It depends on what your requirements are. If I'm using the same parameters for phase 2, I can just use the same transform set. What if they're different? I can also do this. If the requirement is that they have what? Different transform sets, I can do T set 1 and T set 2. This one is 1 and this is 2. But I won't do it if they are the same. I can use the same one. SHA for phase 1. They don't. Where? At the offset, right at the start, as soon as interesting traffic comes up, it says, I need to set up a tunnel. So when a traffic comes up that matches the ACL, it sees that there's no existing session keys established. It goes and says, oh, I need to establish a session 1 or phase 1 with this guy. And that's where it exchanges all the phase 1 policies up front. When the interesting traffic comes up. So the tunnel does not get up automatically. It waits for what? It waits for interesting traffic to come in. Good? Last step. Apply the crypto map to the outgoing interface. Otherwise, if you don't do it, it's all under the interface. If the crypto map is not under the interface, it's not going to encrypt anything. So my outgoing interface, whatever that happens to be, let's say E0/0 or S0/0, whatever you want to set up. The way you apply it, crypto map, whatever you called it. I called it CMAP. Understood? Let's do it then. I'm going to use GNS to do this. I'm going to set up a topology real quick. No, the message does not come up that tunnel is up because there is no tunnel. This is all policy based. So what I'm going to do over here is I'm going to put 4 routers on this topology. Router 1 as one of the sites, router 2 as my second site, router 3 as my third site. Router 4 in the middle is going to act as the ISP. Let's just use a serial interface. R1 to 2, 4, 2, and 3. I'll fire the routers up. That is application specific, Sinan, in terms of the application having an issue with the MTU size increasing. So what you need to do is you need to bring down the MTU size on those interfaces. But that is specifically for what? Applications that have an issue with the maximum segment size and the MTUs. Some do, some don't. So this one will say on the public side, again, every application would have its own recommended sizes because applications are very specific to the way they work. So you cannot say one is good for everyone. So I have these as my public networks. My private networks, let's say, is 10.1.1.0, and I'll put another one over here just so that you guys understand there's other networks behind what? These edge routers. You guys understand that? Everybody okay with the topology? This guy in the middle is acting as what? As my ISP over here, R4. Okay, I'm going to create loopbacks to simulate 10.1 and 10.11. Let's fire these devices up. Connect to the console on all these devices. I'll set up my ISP first. My S00, which is my first interface, is connected towards R1. Let's say 10.4. My second one, I'm going to say 20.4, which is connected to router 2. S01, I've done already. S02, I'll say is connected to 30.4. If I go back to my diagram, S00 is this interface over here. Connected towards 10, I put my address as 4. S01 towards 2, I put my address as 4 on the 20 network. And S02 towards 3, I put .4 as my network on the 30 network. You take a look at these interfaces over here. 10.4, 20.4, and 30.4. Good. They're down because I have not configured the other side yet. So let's do router 1 first. I'll say this guy is 10.1. His default gateway is going to be what? 10.4. Guys, pay attention now. It's the actual configuration. interface loopback 0, which is my inside network, and loopback 1, which is the other inside network, which I'm not going to use for encryption right now. So if you take a look at my interfaces, I have my serial interface connected towards what? The ISP, and these are my two inside LAN segments. Show IP route should show me my default gateway is pointing towards 10.4. So now I should be able to reach my ISP, which is 10.4. R2, same thing. .20.2, I'll set my IP as 2.2. My default gateway, 20.4. My inside networks, show IP interface brief. Good. Now I should be able to ping my ISP, and I should also be able to ping R1, which is a public address on the internet. So right now I have reachability between what? R2 and R1 over the internet. What's the third guy? R3. Let's set that up as well. Let's say 30.3. I'll create my loopback, my internal networks, and my default gateway, which will point again towards the ISP. 10.1 pingable, 20.2 pingable. So these three devices could be anywhere around the world. As long as they can reach their ISP, the ISP should get them to the other sites. Good so far. Any questions, guys? So let's do some IPsec then. Remember this config? Let's go through it and then apply it. I'm doing this on R1, right? So I'm setting up a policy towards what? R2. Let's say this is the policy towards R2. It's using triple DES and MD5 for phase 1. Policy 2 is towards R3, which is using what? Triple DES and SHA for phase 1. Configuring the parameters, tset1, I'm using triple DES and MD5 for phase 1, triple DES and SHA for phase 2. Both of them for phase 2, but for what? Two different clients. One for, let's say, R2 and the other one for R3. Could they be the same? Can I do this? Let's just use a common one so that we can see that you can have the same one. Could I do this? Use the same common phase 2 parameters, although my phase 1s are different. Absolutely possible. I need to define my traffic. So my interesting traffic from R1 to R2 is 10.1 to 10.2. And the traffic that's interesting from 1 to 3 is 1 to 3. Two different ACLs. Has to be two different ACLs. Step 1, phase 1. Step 2, phase 2. Step 3, interesting traffic. Step 4, my crypto map, where I bring everything together. If you look at my network over here, what do you guys see? I only have one outgoing interface. Right? If I have one outgoing interface, that means I can only apply one crypto map. But I need to have a crypto map that will have a tunnel from what? R1 to R2 and a different one from R1 to R3. The way I accomplish that is by using these sequence numbers. That's what the function of the sequence numbers is. Sequence number 5 is my first tunnel, which is going to encrypt traffic based on interesting traffic of what? 101, which is 10.1 to 10.2. If traffic comes in 10.1 to 10.2, send it towards what? The public address of R2. And that's where it goes and sets up phase 1. Once phase 1 is set up, I get the session key. I need phase 2 parameters, tset. I don't have one, I just used the common T set. But for phase, the second one, from 1 to 3, ACL is 102. The destination public address is 30.3, same T set. And the last thing, apply it to my interface, which I will do. So I'll copy this and go to router 1 and paste it. Check to see that there are no errors. This one was an error because I put R1 at the top, which is fine. Phase 1 looks good. Phase 2 looks good. My interesting traffic looks good. Crypto maps, I have 2 crypto maps. All the commands took, and I applied it. What do I need to do on R1? Sorry, R2. I'll copy the same things for R2. But I don't need 2 policies because I'm just doing it from what? 2 to 1. And you guys remember, I'm just using what? These policies. I don't need the policy from the other side. I don't need the second key. I just need the first key because I'm just doing it from 2 to 1. And the address will be from 2 to 1, which is going to point towards what? 10.1. My T set is the same because it's the same for everyone. Define my ACL. I don't need 2 ACLs. I just need 1 because I'm just going from 2 to 1. And not only that, I need to flip it. What used to be source now becomes the destination and vice versa, because the traffic from 2 will go from 2 to 1. Over there was going from 1 to 2. Crypto map, I just need 1. Set peer will change to what? 10.1. I don't need this. That is correct. Purpose of phase 2 is to generate the session key that will be exchanged in phase 1, but used in phase 2. You guys okay with this? Let's do it. Copy it. Let's go to 2. Paste it. Now, is the tunnel up at this point? How do I verify? Show crypto, ISACamp, SA. SA stands for Security Association. Doesn't show you anything over here. Why not? Why isn't showing you anything over here? The interesting traffic has not yet come up. No, it's configured, absolutely configured. Both the sides are configured. So once I generate some traffic, ping it, it will see that interesting traffic came up. I will bring the tunnel up. Which tunnel? First one, exchange the traffic. Sorry, exchange the session key. Get the session key exchange. Go to phase 2. Let's take a look. Nothing over here right now. Ping 10.1.1.1 from 10.2.2.2. I'm on R2, I'm pinging R1. This is interesting traffic. The packet gets created like this. Source, destination is 10.1.1. It hits the outside interface because my default gateway is pointing to the outside. On the outside interface, it sees what? Crypto map, CMAP. Says, hold on a second, let me see it's interesting or not. Yes, it is interesting because it matches the ACL. Says, oh, this is interesting traffic. I need to do what? See if I have a session key already there. It doesn't see a session key. Says, oops, I need to set up phase 1. Sets up phase 1. What happens in phase 1? It sets it up based on the key encryption and hash, exchanges the session key that is generated by Diffie-Hellman. Once this exchange takes place, I'm ready for what? Phase 2. What happens to phase 1? It stays there, but it stays in what is known as the idle state. It'll be idle. Why? It's done its job. It's exchanged the session key. I'll go to sleep. For how long? 1 hour. Why 1 hour? It'll be idle in 1 hour because the default session lifetime for the session key is what? Which is 1 hour. Right? After 1 hour, it's going to wake up again, exchange the key, go back to sleep. So generally, you're going to see this in idle. Idle is good. Idle is not bad. Means it's up, it's done its work, it's sleeping. Let's do that. Ping. The traffic is encrypted. Or sorry, traffic is going through. It generally does for phase 1. Phase 2, everybody is, for the session key, generally they set it to, defaulted to 1 hour. For phase 1, it changes. So the first phase is some vendors have it at 8 hours, some have it at 24 hours. The lifetime of the first phase in Cisco is 86,400. That's for lifetime of phase 1. Phase 2 generally is 3,600. The session key is normally 3,600. For phase 1, generally, you're right, it varies, but that doesn't matter. Phase 2 is the one that is the key one. That is 3,600. So now it's going through. Understand one thing. What did I ping? I pinged 10.1 to 10.2. Through what? Through router 4. Router 4 has no idea about 10.1 or 10.2, does it? It's in the internet. It's on the internet. It does not understand what? The private addresses. It only understands public addresses, but I am sending traffic from where to where now? I'm sending it from R2 to R1, 10 addresses going over the internet. Okay, so just to show you, if I go to router 4, what are the only networks it knows about? The public. It has no idea about 10.1 or 10.2, but it's still sending the traffic across. Why? As soon as the packet came in, it came in like this. Into router 2, but because of the IPsec, it puts an outer header saying, I want to go from 10.22, 10.1. This part is encapsulated and encrypted by whom? What is the protocol that's doing it? ESP. So the outside, the ISP will only see this packet. This part over here will be encrypted and encapsulated. How does it know to go to 20.2? You put that in your config, or sorry, from 20.2 to 10.1, you put it in your config. Where? Let's go to router 2. Show run section crypto. Didn't you say that if this traffic comes in, which is 10.1, 10.2 to 10.1, send the traffic towards what? This becomes your public destination. Source is your interface that you apply it to, which is 20.2. So 20.2 to 10.1. The outer header. Now, do I know if the traffic is getting encrypted or not? There's another show command for that. Show crypto IPsec SA. SA stands for Security Association. This is your second phase. It's telling you that 4 packets were encrypted and decrypted. All right? This is the key ID. It's not the key, but the key ID for your session key. Encrypting using this as your transform set. If I do another ping over here, I've sent another 5 packets. What's going to happen over here? 5 more packets are encrypted. So you know that your traffic is getting encrypted. No, you can't see the key. You can see the key ID. That's the whole purpose, man. You want to keep that key secret. But this is the key ID. Good so far? Now, we've done what tunnel? Absolutely. Remember the first time I ran it, it gave me nothing? Oops, not this one. It's up. It's going to stay up for how long? The default time is 86,400 seconds. Just to let you know that it's 24 hours. So this tunnel is up for 24 hours, but what's it going to do? Nothing. It's going to sleep. It's just going to wake up at the top of the hour, exchange the key, go back to sleep. It's just used to exchange that session key. Clear. There's 2 tunnels, right? Phase 1. And there is a tunnel called phase 2. Phase 1 stays up without any reset up for 86,400 seconds. But inside phase 1, every hour, I'm going to exchange what? The session key. The lifetime of the session key is 3,600 seconds. So basically phase 2 will remain up for what? 3,600 seconds. After 3,600 seconds, this session key will expire. They'll exchange a new session key, which will go for another 3,600 seconds. But this tunnel will stay up for 86,400 seconds. As soon as another interesting traffic comes up, it comes up automatically. So really, you don't need to do anything about it. It'll just do it in the background. As soon as it detects any traffic, it will come up and send the traffic across. During rekeying of phase 2, there's no traffic interruption. Even if it is, it is basically transparent to the end user. When you go to the internet, do you think every packet that you send to the internet is going there without retransmissions? No, it's not. So you have retransmissions, but the end user doesn't see it. But if you really want to nitpick and you do a ping, you'll see there's about 2 or 3 drops. But it's transparent to the end user. He won't notice it. It's a single packet drop, actually, not even multiple packets. It's a single packet drop. Clear, guys? Everybody okay with this? That is between what? R1 and R2. I've also configured a tunnel from what? R1 to R3. Let's do the R3 portion of it. What I'm going to do, that's the reason I do this in Notepad, because I can reuse it. I'll go back to R1 and I'll copy what? the same config and change it to match what? R3. So if you guys remember, we're using what? These parameters for R3, the second set. That's the whole purpose of doing policy 20 for phase 1. I don't have this key. Instead, I have what? This key. Again, he is also going to go to what? From 3 to 1. This one is the same because I use the common phase 2. This thing, I don't need 2 ACLs. I just need 1 ACL. I'll just call it 101. And that is going to be from where to where? Flip the source and destination. When I go to my crypto map, I'll match ACL 101. Destination is 10.1, same transform set. I don't have a second one. And apply it. These are the 5 steps that you need to do to set up a LAN-to-LAN IPsec VPN. Why is it called LAN to LAN? The reason it's called LAN to LAN is because you're doing it between what? 2 LAN segments. The end devices are completely unaware of VPNs happening. So 10.1 does not know it's going through a VPN. 10.1, you don't need to configure anything about a VPN. He has complete no knowledge about a VPN happening over here. So I'll copy this, go to router 3, set it up. By the way, I'll share this document with you guys at the end of the class, so you don't need to type it quick. Let's do the ping now, or let's do the show commands first. No tunnel over there. 0 packets encrypted. No session keys over here. Okay, now what I'm going to do is I'm going to do the ping from where? I'm going to ping 10.1.1.1 with a source of 10.3.3.3. Absolutely, Sanjay. That was the question that you had earlier on. Why do they call it a VPN? Virtual private networks, allowing private networks to communicate over the internet. Pinging. So again, how do I know it's working properly? Set to idle. And this is your test that 4 packets are encrypted, decrypted. If you do another ping, another 5 packets. It tells you what? The traffic that is getting encrypted. And now you will see an outbound and an inbound key. Outbound from me to him, inbound from him to me. Somebody asked me that question earlier on as well. Are there 2 tunnels? Yes, there are 2 separate tunnels. One is an outbound, one is an inbound. They use different session keys for each one. No, it's not dropped. Ping has a lifetime, right? But because it took some time for the tunnel to come up, I did send it, but by the time the device has already timed out on the ICMP. Remember the ICMP timeout? That's why. It was not dropped. It was sent, but by the time I got the response back, the end device said, oh, timeout, the ping didn't come back in time. What is the encrypting key from A to B will be the decrypting key for me, and vice versa. So for example, if you take a look at it, what's the inbound key over here? Just remember the last 4 numbers. What are those? 9463, right? This is going to be the outbound key for what? R1, for this from 1 to 3. So if I do show crypto IPsec SA, not this one, this is 2 to 1. I want to look for what? 1 to 3. So that should be the outbound for this guy. What are the cons of using group 3? It's more secure, which is a pro. The bad part is more time to encrypt and more time to decrypt. so it's going to be slower. Everybody okay with this? You understand the commands? It just requires practice. But this is it. These are the 5 steps that you need to remember. The base is the same, just builds on top of it. Everybody good with this? Any questions about this? By the way, just so that you are wondering, I'm not going to do it, but I just want you guys to see this. Crypto map, III, 10. Take a look. The stuff that you never even take a look at, there is an IPsec manual. And if you do that, then you need to set your session key over here, inbound and outbound manually. That's how you do your session key manually. I would not recommend doing it, but this is where you do it. Remember, I told you that you can do your session, you can do your IPsec without doing what? Phase 1. This is how you do it. Now I don't need ISACamp at all. But now I need to set the key, the session key manually. Everybody good? Which tunnel uses a local session key, inbound or outbound? The inbound key is the other guy's key. The encrypting key is the local key. The other thing, the lifetimes. Remember I told you the 2 lifetimes? The first lifetime, which is your ISACamp lifetime, is done over here. The default over here is 86,400. 24 hours. That's the default. This is for phase 1. The lifetime for the other one is over here. This is defaulted to 3,600 seconds. So if you want to change it, this is where you change it. What are the most tunnel flap issues? Generally, your applications. Your applications have an issue with the MTU and the maximum segment size. That's where they normally have issues. This is symmetrical crypto, right? Because it uses the same key to encrypt and decrypt. All of them use that. For phase 2, it's always this way. For phase 1, inbound and outbound both use the same key for IP1. That is correct. Unless you are using your PKI, public key infrastructure, which uses the public-private key, which is different. We haven't talked about it. When we do the certificate authority and CA servers, we'll talk about it at that time. If you have the same, what Manny is saying is you have 10-1 on both sides. Is that what you're trying to talk about, right? You have to do NAT. So you need to NAT the address. So you do NAT prior to doing IPsec. No magic, you need to do NAT. Yes, CA server. This part over here. H is out of the window, but transport and tunnel mode, I will definitely do that. ESP, transport, ESP, tunnel, we'll do both. We'll actually do it. BGP, no, not on this one. More on the service provider side, yeah. All right, let's take a short 10-minute break. It is 8:40 right now. We'll come back, at least knock out GRE. I want to do this part at least today. Take a 10-minute break. We'll come back and do it. So looking at the time, it is, I can see this. Can you guys see the 8? Yeah. 8:40. Take it till 8:50. We'll come back. We'll take a look at GRE, which is a basic topic, but I want to knock that out before we're done today. So tomorrow we can concentrate on GRE IPsec, which is your transport tunnel modes. We'll also do SVTI and DMVPN tomorrow. Let's take a short break. All right, guys, let's continue on. My email address. You don't have my email address. I have two. I'll give you both. Either one is fine. They both come into the same place. Deepthi, in terms of the workbook and IOU's labs, I'll send it to you tomorrow. All right, everybody back. All right, so the next thing I want to take a look at is the GRE tunnel. Now, this type of tunnel that I set up over here, this type of VPN, I should say, that I set up over here to connect R1 to R2, or I used it to connect to R3. The traffic that was sent over the VPN tunnel was established or set up in an ACL. Yeah, Rinchin, we'll do NAT-T and without NAT-T when we get to the firewalls. There's a specific thing that it works with the firewalls that I need you to be aware of. So once we do the firewalls, at the time, just remind me, I'll do a LAN to LAN with and without NAT-T. So right now, when I did the policy-based VPN, I did defining of my traffic based on an ACL. Agreed? So ACL defined or specified what traffic should be encrypted and decrypted. You guys agree? This type of VPN is classified as a policy-based VPN. Because a policy, which is your ACL, defines what traffic needs to be encrypted. Agreed? So the VPN that I set up over here is a policy-based VPN. Any type of VPN in which the ACL defines the interesting traffic is policy-based. The policy being your ACL. What's the drawback over here? The drawback is the static nature. What do I mean by it's static in nature? Right now, I had 10.1 encrypting to 10.2, right? Let's say I also wanted 10.11 and 10.12 to be 10.11 to 10.22 to be encrypted. What would I need to do? Users you don't have, you have, these are LANs, LAN segments. So if I wanted to encrypt 10.11 to 10.22 as well, take a look at the ACL entry. So right now my ACL entry was 10.1 to 10.20, 10.2. And over here my ACL was 10.2 to 10.1. Let's say now I want to do 10.11 as well. I need to update the ACL over here. And I need to update the ACL over here as well. Both sides, just like you do in static routes. What if you want to do 10.22 as well? So I would need to do what? Add 10.22 to 10.1. And I need to add 10.22 to 10.11. Over here, what do I need to do? 10.1 to 10.22 and 10.11 to 10.22 manually. I need to add these things manually on both sides. You guys understand that? If I add another network over here, and I add another network over here that I want to be encrypting from, what do I need to do? Add this new network manually over here. 172.16.1.0 should be encrypting towards 10.2, 10.22, and 172.16.2.0. And on router 2, what am I going to do? 172.16.2.0 should be encrypting towards 10.1, 10.11, and 172.16.1.0. So it's very what? Static in nature. So as you add more networks, it becomes static. That's where GRE comes in. GRE is a protocol that allows you the ability to set up an actual tunnel interface between what? The two endpoints. Right now, did I create a logical interface between R1 and R2 when I was doing the VPN? No, it was all done based on the policy. This traffic coming into that traffic, I'll encapsulate it. With GRE, I have the ability to create a tunnel interface. A logical interface, which logically would connect R1 and R2 to each other, and I would assign this tunnel interface a common IP address, as if I'm connecting what? R1 to R2 over this logical interface. They're joined together over this logical interface. On this tunnel interface, I'm going to specify any packet that leaves this tunnel interface will have a tunnel source of 10.1 and a tunnel destination of 20.2. This becomes your tunnel source and destination. What do I have as a tunnel source over here? The public address of R2, and the destination is going to be the public address of R1. So now that I do that, I actually logically have connected R1 and R2 to each other. So logically, R1 and R2 are connected to each other over this tunnel network called 192.168.1.0, which is an actual logical interface. IPsec did not give you that capability. Because they're connected, I can run a routing protocol. Over what? Over my local networks and over my tunnel network. Why? Technically, logically, R1 sees R2 as a directly connected network. So when a packet comes in, when I run EIGRP, let's say as a routing protocol, or RIP as a routing protocol, I enable it not on the physical interface, but on the tunnel interface. So on the tunnel, I've specified any traffic that needs to go over the tunnel will have an outer header of what? So it encapsulates the packet, and on the inside, let's say it's an EIGRP update. It's going to say 192.168.1.0 or 1.1, which is my source of the tunnel, which is the IP address of the tunnel interface. Destination is 224.0.0.10. So I'm going to exchange what? Routing updates with each other. He's going to see this now as either RIP or EIGRP, whatever your routing protocol is, as 10.1.1.0, reachable via, this is the outer header. Has to be, right? This is the public side. This is the private side. Via 192.168.1.1. Tunnel 1 is the IP. So because of the routing, it will learn that 10.1.1 is reachable via what? Tunnel 1. So if I sit over here and I say ping 10.1.1.1, what's going to happen? It's going to check the routing table, sees 10.1.1 is reachable via the tunnel interface. So whenever this packet comes in, the outer header is going to remain the same. The inner header, based on the routing, it'll say 10.1.1 wants to reach 10.2.2, and so on and so forth. So technically, I'm connecting the two routers to each other as if they're directly connected. What I'm going to do over here is I'm going to shut these routers up, restart them. I'm going to create a tunnel interface, GRE tunnel between what? R1 and R2. Let's go to router 4. Set the internet up first. Still coming up. This is the ISP. It's the same topology that I used over here. I just restarted it because I didn't want to have that IPsec configuration on it. This is the interface towards R1. This is R1's default gateway. Just going to do 1 and 2 for right now. R1. My public IP is 10.1. My inside addresses, which are simulated based on loopbacks over here, and a default gateway towards what? 10.4. R2, 20.2, the inside, and the 22. (24) is my default gateway. So I should be able to ping on the public side. R1 and R2 are talking to each other on the public IPs. Good. My objective is to allow them to communicate on what? The privates. So I want to do the routing bit. How do I do it? How do I create a tunnel interface? Very simple. R1, interface tunnel 1. This is the logical tunnel interface I'm going to create between what? Did I do that for IPsec in the previous example? No. I defined what traffic was interesting based on what? The policies. Here I'm going to say the tunnel starts at 10.1, and anything that leaves the tunnel will have a destination of 20.2, the two public addresses of R1 and R2. It is a point-to-point tunnel. All right. And what do I do on R2? R2 is also on the same logical interface or network. It's just .2 on that network. It's a point-to-point tunnel. He will start his tunnel from where? That means any packet that leaves the tunnel interface will have a source of 20.2 and a destination will be R1. It is a point-to-point tunnel. But now because I have an actual network that connects me to each other, I can run a routing protocol. Let's run EIGRP on the tunnel interface and all my 10 networks. And I'll do the same thing on the other side. Now I'm learning each other's routes through this logical network called a GRE tunnel interface. Let's do this on router 1. And we will do the same thing on router 2. As soon as I do that, because I'm running EIGRP, if everything's hunky-dory, my EIGRP neighbor relationship should come up. It will depend on your routing protocol. Generally nowadays, it's all based on session. Forget about the load sharing. Let's focus on the first one coming up. But to answer your question, generally today, in today's day and age, it's normally based on flow-based. So my tunnel is up. How come? Because the two routers now logically have a common interface among them. What is that interface? It works on the premise that any traffic leaving what? My tunnel interface will have a source and destination defined. So when I told it that I want to run EIGRP on the tunnel interface 192.168.1.0, it sent an EIGRP update like this, normal EIGRP hello packet. But because it was set to the tunnel interface, anything leaving the tunnel interface, what does it need to do? It needs to put the tunnel source, tunnel destination. So the router 4 just looks at the outer header. He doesn't care what's on the inside. This is a GRE packet. Nope, we'll do the VTI part later on. This is a GRE tunnel. Do you get my point? The good thing now is it's dynamic. So if I add a new network over here, all I need to do is advertise it in what? My routing protocol, it will tell the other guy. Just like normal dynamic routing, I don't need to go to both places and do that. Some show commands to check this. Over here on router 1, show IP route, you will notice that I have a whole bunch of EIGRP routes over here. If I look and do EIGRP, this is the routing. I've learned the 1022 and 10.2 networks via what? This guy, which is the tunnel interface. Now, if I take a look at my interface itself, has a tunnel source 10.1, destination 22, which I defined. The protocol is GRE. You guys get the point? The drawback, yes, it's very dynamic, but it's clear text. It is encapsulated, it's not encrypted. Encapsulated means one packet within another, but it's not encrypted. The guy in the middle can actually see the data. It is clear text. Let me see if I can, my Wireshark is running. If it is, I'll show you the actual packets. Yep, it's running. Take a look at this packet. This is an EIGRP hello packet that's going across. Source of 20.2, destination of 10.1. Protocol GRE. Inside there, there's another header. What is that? 192.168.1.2 going to 224.0.0.10, which is the EIGRP multicast packet. If you open that up, you can actually see the entire packet. The K values will show up. Your software revisions will show up. If there's an update going across, you'll see that as well. Let's do that real quick over here. I'm going to go to router 1 and create a loop back. Let's say 7, 172.16.1.1, and advertise it in where? In EIGRP. So if everything's fine, it should send that as an update somewhere. See this? Update. From where to where? From 192.168.1.1 to 192.168.1.2. What type of update? EIGRP update. Let's take a look. Guess what? It's advertising the 172.16.1 network that I just added. I can see the packet. Yes, it is getting encapsulated. Encapsulated means what? The outer header, router 4 in our case, is using this to forward it. But if he wants to, he can see the inside packet, which is clear text. This is still a VPN. We'll do that when we do IPsec with it. But understand GRE for right now. It's still a VPN. What's a VPN? Connecting two private networks to each other. I'm connecting 10.1 to 10.2. But it's not encrypted, it's clear text. It's still a VPN. It's a layer 3 VPN. What's the protocol that I'm using to do it? It's called GRE. Makes sense, guys? You guys understand this? And these two routers could be on two edges of the world, doesn't matter, as long as they have reachability to each other. That is GRE. Very simple to set up. I just want you guys to see how it's done. Let me save this document now. Classes, I'll do the annual pack for this one. What is today? 8-19. This is your config for GRE VPNs. Very simple to set up. Now for tomorrow, good stuff. We'll do GRE in conjunction with IPsec. We'll do transport mode. Actually, we'll start with tunnel mode. We'll do GRE IPsec in transport mode. I'll explain what the differences between the two are. We'll also do native IPsec tunnel, which is also known as SVTI. We'll do MGRE and we'll do DMVPN tomorrow. Packed session tomorrow. IPsec NAT-T, as I said, I'll do it at this point. I need some natting to be done. So once I do this part over here, just remind me. I'll do IPsec NAT-T at that point. So once I'm done with NAT, I can show you this at that time, the NAT-T part. Good, everybody? We'll do that. You guys, some of you guys were here for the demo. So if you want to join, just let me know. Send me an email, and I'll sign you guys up. I'll create what do you call it? I have an email list. I'm going to use the same email list today to send the files. So if you guys, not you, for instance, some other guys had joined in just to see the class, how the class was. So for those guys, if you want to continue on for tomorrow, let me know. I'll send you the link to join. I'll send you the book. Once we're done with that, the rack for this, at this point, I would just do this on your GNS. It's good enough. If you want, tomorrow I'll show you how to set up GNS for this. I'll give you the files. You can download them. For this type of stuff, don't waste your time on the rack. All right, guys? No, it's a physical rack with virtualized equipment with it as well. So for example, FTD, ESA, WSA, these are virtualized, what do you call it, images, but you have the physical rack. It has the physical routers, which I need for your ICE. You have physical ASAs, which I need for clustering. So it's a combination of both. just like the normal rack on the exam. Zahir will do that. It'll probably be tomorrow morning because it takes time for this to render the file. And I'm going directly into another class right in about 10 minutes. All right, guys, you take care. See you guys tomorrow. Sure, Shahnawaz, no problems. I'm not going to call you Manik, so I'm not going to note it. Take care, guys. Bye.